Okay, dear students, in the previous class we discussed about the distance formula in coordinate geometry class 10th. Today we want to discuss about the section formula. Section formula. Okay, students, today we want to discuss about the section formula. In that section formula, in the previous class already you know the quadrant. Here this is x-axis, this one is y-axis. The two x-axis and y-axis meet at the point. This one is known as origin, usually denoted by O. Today we want to discuss A and B. A and B. In these 2 points, A x1 y1, B x2 y2, two coordinates. The distance here, any one point, P is an any point, divides this line AB internally in the ratio of M1 is to M2. We want to find the point, midpoint, that is here X and Y. X and Y. Now, if you want to find the section formula, you have to draw a perpendicular line A to x-axis and B to x-axis and even P to x-axis also. You give one name A, B and P. Here C, D and E. And now you draw one parallel line to A, M, you take it. AM perpendicular to PD, and similar PN perpendicular to BE. Already we know that distance between the OC is equal to x1 and distance between the O and D, because here x coordinate, and distance between the O and E, here also x coordinate x2, here x2, distance between these two is equal to x2, and the length of AC is equal to x1, length of AC is equal to y1, and length of PD is equal to y, because coordinate of P is y and coordinate of point B is y2. This one is y2. Length of this one is y2. Now see that we'll get the two triangle PAM and BPN. These two triangles are similar triangles because it is also a right angle and it is also right angle, and this AM parallel to x-axis and PN is also parallel to x-axis. Therefore these two angles are corresponding angles. This two angle is also equal. Therefore these two triangles are a similar triangles. Therefore triangle APM similar triangle to BPN. These two triangles are similar triangles because AA similarity. According to AA, two angles are equal in these two triangles. Therefore, these two triangles are similar triangles. When they are similar triangles, we may apply the basic proportionality theorem. Therefore, AP divided by PB, which is equal to AM divided by PN, which is equal to PM divided by BN. This is equation number 1. Now we know that AP divided by PB means length of AP is M1 and PB is M2, which is equal to M1 divided by M2. And now you take AM. here see that AM is equal to CD, AM is equal to CD, AM is equal to CD, which is equal to CD is equal to OD minus OC, OD minus OC. OD means here X minus X1, X minus X1. Similarly, you take PN, Pn here Pn is equal to DE, Pn is equal to DE, DE is equal to OE minus OD, OE means here x2 minus x, therefore here Pn is equal to DE, which is equal to OE minus OD, OD, OE is equal to x2 minus x, x2 minus x. Then you take PM, PM is equal to PM, here PM is equal to here this one PD minus MD, MD is equal to AC, therefore here PM is equal to PD minus AC, which is equal to Y minus Y1. And similarly you take BN, here BN, only this part you want to BN is equal to BE minus PD, BE minus PD, that is Y2 minus Y, therefore here PN is equal to BE minus PD, which is equal to Y2 minus Y. Now all these values substitute in the equation number 1. Equation number 1 is AP divided by PB, which is equal to AM divided by PN is equal to PM divided by BN. This is the equation number 1. Now you substitute AP divided by PB. AP divided by PB means M1 divided by M2, because P divides the line AB in the ratio of M1 is to M2. Here M1 divided by M2 is equal to AM. AM is equal to X minus X1, X minus X1 divided by PN. PN is equal to X2 minus X, X2 minus X, and is equal to PN. PN is equal to Y minus Y1, and BN is equal to Y2 minus Y, Y2 minus Y. Now these three are equal, therefore you have to take this 2 is one time equal and this 2 is another one time equal, therefore M1 divided by M2 is equal to X minus X1 divided by X2 minus X, and M1 divided by M2, this is also equal to this one Y coordinate, Y minus Y1 divided by Y2 minus Y. Now you find the X coordinate and Y coordinate here, therefore you take it, first one cross multiply, therefore M1 into X2 minus X, which is equal to M2 into X minus X1. Multiply this M1 X2, M1 into X, M1 X, which is equal to M2 into X, M2X minus M2 into X1, M2 into X1. Now you rearrange this X2 and X1, write it one side, and M1 X2, if minus M2 X1, if you transfer to LHS, it become plus M2 X1 is equal to M2X minus minus m1x. If you transfer to LHS, it become plus m1x. Therefore, in this two term, now you take this one transfer to LHS. You take x is a common, x is a common, x into m2 plus m1, which is equal to m1 x2 plus m2 x1, or only x is equal to this one you transfer to LHS, then RHS, then it become m1 x2 plus m2 x1 whole divided by m1 plus m2. This is the coordinate of x. Similarly, you take a coordinate of y. Here, cross multiply. If you cross multiply m1 into y2 minus y, which is equal to m2 into this one, therefore m2 into y minus y1. Again multiply monomial into binomial, m1 into y2, m1 into y2 minus m1 into y, which is equal to m2 into y, m2y minus m2 into y1, m2 into y1. Again this y1, if you transfer to LHS, it become plus m1 y2. Here this one, if you transfer to LHS, it become plus m2 y1, which is equal to m2y minus m1y is there. If you transfer to RHS, it become plus m1y. Again in this two term, y is a common factor, therefore take it y, m2 plus m1, which is equal to this one, m1 y2 plus m2 y1. Only we want to y coordinate, therefore this one you transfer to LHS, y is equal to m1 y2 plus m2 y1 divided by m1 plus m2, m1 plus m2. This is the y coordinate. Total this point is both x and y coordinated there. This point is divided internally in the ratio of m is to n. Therefore, coordinate of point P is equal to both x coordinate and y coordinate, x and y. Therefore, x and y, which is equal to m1 x2 plus m2 x1 divided by m1 plus m2. This is x coordinate. And similarly, you take y coordinate, m1 y2 plus m2 y1 divided by m1 plus m2. This one is section formula. This formula is called section formula, because the point P is divides internally, not externally. Points P divides internally in the ratio of m is to n. Then we may apply x y coordinate is equal to m1 x2 plus m2 x1 divided by m plus n. This is the x coordinate, and y coordinate is m1 y2 plus m2 y1 divided by m1 plus m2, or sometimes m2 plus m1. Both are same. This one is called section formula. Okay, thank you.